All right, Unit 1, Part 2. Let's get this party started. So in Part 2 of Unit 1, we're going to address the following 5 topics. First, induction and deduction. You may be familiar with both of those terms, although maybe not in the way that we'll use them in this class. Induction doesn't have to do with electricity, by the way, that's conduction. And then deduction. If you've watched that popular show Sherlock, that term gets thrown around a lot. But we're going to get a little bit more precise on what we mean by that. Second, we're going to look at form and validity. And you'll understand what that means when we get to it. We're also going to look at truth and validity. And then finally, we'll look at the nature and scope of symbolic logic. So this is also kind of an overview of what we're going to be covering for a good chunk of the rest of the semester. All right, well, take the following 2 arguments. Argument 1. Davis is better looking than David. David is better looking than Justin. So, Davis is better looking than Justin. Then take a second argument. Davis's hair is ruffled, his eyes are baggy, he is cranky, and he's avoiding eye contact. So, Davis just woke up. All right, these 2 arguments are arguments for sure, but there's something different about both of them. Well, let's take a look at the first argument. The first argument is what logicians call a deductive argument. In this particular argument predicates what we'll call the transitive relation of better looking than between Davis and David, David and Justin, and then between Davis and Justin. Davis is better looking than David, David is better looking than Justin. I'm not going to say whether or not the premises are true, I'm just pointing out the structure and type of argument that it is. All right, the second argument, however, is what logicians and philosophers call an inductive argument. And this lists a number of features about Davis and then draws a conclusion about Davis based on those features. But what does this tell us about the difference between deduction and induction? Well, the distinction between an inductive and a deductive argument lies in the intended strength of the connection between the premises and the conclusion. In a valid deductive argument, true premises guarantee a true conclusion. If the premises are true in a valid deductive argument, then the conclusion is certainly true, or the probability that the conclusion is true is 100%. Okay? On the other hand, in an inductive argument, the premises render the conclusion more probable. Thus, the conclusion of an inductive argument is often indicated by the term probably. Let's go back. This first argument, if it's true that Davis is better looking than David, and if it's true that David's better looking than Justin, then, since better looking than is a transitive relation, it's 100% true that Davis is better looking than Justin. On the other hand, even if it's true that Davis's hair is ruffled, his eyes are baggy, and he's cranky, and he's avoiding eye contact, it's probably true that Davis just woke up, but there's other things that you could also conclude from it. For example, that Davis just got beat up, or that someone just injected Davis with certain drugs. So there's other things that could follow from kind of these bits of information. So that's the difference between induction and deduction, the strength of the connection between the premises and the conclusion. All right. Well, let's talk more about inductive arguments. Take the following inductive argument. Most of David Hasselhoff's songs have been hits in Germany, so his next song will probably be a hit in Germany. Well, it's possible that the conclusion be false in this argument, even though the premises are true. Thus, there's what logicians call a logical gap between the premises and conclusion in an inductive argument. However, with deductive arguments, there is no such logical gap between true premises and a conclusion, if the argument's valid. So, again, in an inductive argument, it might be true that every single one of Hasselhoff's songs have been hits in Germany, but his next song might be strongly disliked. By the way, I should just indicate that I'm a scholar of German philosophy, and my dissertation's on the German philosopher William Gottfried Leibniz. I've spent numerous amounts of time studying in Germany, and I know that most people today in Germany aren't wild about David Hasselhoff. Just to clarify that. I'm just using this for the sake of example. Alright, this doesn't mean, even though that you can have all true premises in an inductive argument, but the conclusion turned out to be false, this doesn't mean that inductive arguments are bad arguments. For one thing, we rely on them for many of our judgments, and we couldn't make our way in the world without them. For example, 99.9% of plane flights don't result in a crash. So, the flight my parents booked to Europe will probably not result in a crash. So, suppose someone avoided flying because of that 0.01% chance of a crash. We would say, and it's probably lower than that. I would say, as a logician, that if they're choosing not to fly because of that low probability of crashing, then they're making a decision not to fly. What leads them to make that decision is basically an irrational inference. Furthermore, if they avoided other activities based on an inference of that kind of probability or likelihood, you wouldn't get anywhere or do anything. I mean, you're also, if you use kitchen knives to cut a tomato, you have a 0.01% chance of slicing your finger off. You have a chance of getting in a car crash. You have a chance of getting killed crossing the street. You have a chance of, just airplanes flying over your house could drop an engine on top of your house. So, we rely on induction then. We make these judgments all the time in our practical day-to-day living. So obviously induction, even though it doesn't get a 100% guarantee of the truth of the conclusion from the premises, that doesn't mean it's a bad type of reasoning, all right? However, for the next few weeks, we're going to be looking mostly at deduction for several reasons. They're more preferable, especially for a beginner logic class. Because, as I mentioned before, in a valid deductive argument with true premises, we can be 100% sure that the conclusion is true. For example, if it's snowing in Chicago, and Chicago's in Illinois, then we can be 100% sure that it is snowing in Illinois. So, and this is important, pay attention to this. In deductive arguments, it's basically an either-or situation. Either the premises provide absolute support for the conclusion, and the argument is therefore valid, or the premises do not provide absolute support for the conclusion, and the argument is invalid. However, in inductive arguments, the goodness of the argument is a matter of degree. Different inductive arguments will have conclusions that are supported to varying degrees. For example, here's an example of a weak inductive argument. My girlfriend hasn't responded to the 5 texts I sent her in the past 10 minutes. She must want to break up with me. Here's one that's a little bit stronger, though. My girlfriend hasn't responded to any of the texts I sent her all day today. She must want to break up with me. It's still a weak connection, but it's a slightly stronger connection between this conclusion, that my girlfriend wants to break up with me, and the evidence, okay? Here's an even stronger argument. My girlfriend hasn't responded to any of my texts today or yesterday, and she acted uninterested in me when I last saw her a week ago before. She must be planning to break up with me. That's a bit stronger of a connection between the conclusion that my girlfriend wants to break up with me and the evidence that I provided. Now we're starting to get a really strong argument. My girlfriend hasn't responded to any of my texts over the past few days. She acted uninterested in me last time I saw her, and there's a picture of her that just pops up on Facebook with some really good-looking guy taken during her business trip in Cancun. Therefore, my girlfriend must want to break up with me. Here's a really strong argument. My girlfriend hasn't responded to any of my texts over the past few days. She acted uninterested in me last time I saw her. And there's a picture of her with some really good-looking guy on Facebook, and the picture looks like it was taken during her business trip to Cancun, and she just changed her relationship status on Facebook. She must be breaking up with me. So as you can see, there's different strengths of connection between the evidence and conclusion of an inductive argument. There's a variability in there, but you can also see it's kind of a spectrum, greater or weaker connections. With deductive arguments, however, it's all or nothing. It's either 100% or it's 0%. There is no 50% within deductive arguments. It's all or nothing. Well, again, though, with inductive arguments, there is a spectrum. There's degrees. So, unlike deductive arguments, there are no sharp boundaries between good and bad inductive arguments. In cases where you can calculate the likelihood, there's just better and worse arguments. For example, if the odds of winning a raffle are 1 in 1,000, and Jane buys 900 tickets, then the conclusion that Jane will probably win is more likely than if Jane bought 900 tickets for a raffle in which the odds of winning are 1 in 100,000. So, in that case, there's a clear-cut answer to the question of the degree of strength between the evidence and conclusion. The evidence being Jane's bought 900 tickets, and the conclusion is that Jane will win the raffle. Okay, you can literally tell the odds in this case. But I should go back though. There are a lot of cases where you can't figure out the odds in this neat type of calculation that fits in an Excel file. Okay. For example, inducing that your girlfriend's going to break up with you from a body of evidence. You can't put a precise number to that. At least not with the tools we're learning this semester. All right. So, like I said, we're going to be primarily concerned with deductive logic. It's more clear cut. It's easier to learn. So we're just going to proceed with that. This leads to two good-making features of deductive arguments. And we're going to spend some time on both, validity and soundness. So there are two good-making features of deductive arguments, validity and soundness. Now, before we discuss validity, we should actually understand what logicians mean by the form of an argument. Because as I mentioned, deductive arguments like serious sports require good form. But what do I mean by that? Well, take the following two arguments. Argument 1. If Rover is a dog, then Rover is a mammal. Rover is a dog, so Rover is a mammal. Argument 2. If the Cubs play in Chicago, then the Cubs play in Illinois. The Cubs play in Chicago, so the Cubs play in Illinois. Well, let's lay these arguments out. Let's kind of make it a little bit more formal. So you can see how argument 1, we'll say it has the first premise, if Rover is a dog, then Rover is a mammal. And argument 2 has a first premise, if the Cubs play in Chicago, then the Cubs play in Illinois. Argument 1 has a second premise, Rover is a dog. Argument 2 has a second premise, the Cubs play in Chicago. Well, notice the connection. This sentence, Rover is a dog, found in premise 2, you find that in premise 1 as well. It's between if and then. If Rover is a dog, then. And then you see it right there, Rover is a dog. Then finally, look at the conclusions that we draw. So, Rover is a mammal, so the Cubs play in Chicago. Well, you'll find Rover is a mammal up in 1 as well, after the word then. Rover is a mammal. Then you find it at the bottom 3, Rover is a mammal. Cubs play in Chicago. You find it up there in 1, Cubs play in Chicago. Alright, this seems trivial and easy and elementary, but pay attention. Both of these arguments have the same structure, and it can be represented symbolically, just like you would represent stuff in algebra. We could say with variables. So, if P then Q, P so Q. It has that structure. If P then Q, P so Q. P, Q, if P then Q, P so Q. Got it? Well, let's let the variables represent the following statements then. P will stand for Rover is a dog. The Cubs play in Chicago. Q will stand for Rover is a mammal. The Cubs play in Chicago. That's a typo. The Cubs play in Illinois. That's not a typo. Well, note how the variables could be used in arguments with different forms. For example, if P then Q, not Q, so not P. For example, if Rover is a dog, then Rover is a mammal. Rover is not a mammal, so Rover is not a dog. Same sentences, just being arranged differently, put into a different structure. Well, this is important, and this leads logicians draw a distinction then between the form and content of an argument. Here's the content. Rover's a dog, Rover's a mammal, Cubs play in Chicago, Cubs play in Illinois. That's the form of one argument. That's the form of a different argument. Okay? So there's a difference between the form of an argument, the structure the argument takes, and the content of the argument. Here's a fun fact. Two arguments can have the same form, but different content. Again, two arguments can have the same form or structure, but different content. And that should make sense by now. So, think about when you go to the medical doctor and you fill out a patient form. Every patient fills out the same form, right? But each form, when filled out by different patients, gets different content. Some people have diabetes, others don't. Some have high blood pressure, others don't. Some have allergies, others don't. Some people take medications, others don't. So everyone fills out the same form, but the forms, when they get filled out, have different content. Well, arguments are the same way. Different arguments can have the same form or structure, but even though they can have different content. Just like you go to a medical doctor in Virginia and you fill out one form, you go to one in Maryland, you fill out a different form. So different forms, different structures, and the same form can have different content at the same medical doctor in Virginia. This should make sense by now. Alright, well, the form of a deductive argument determines whether or not the argument is valid. When a deductive argument has a valid form, necessarily, if the premises are true, the conclusion is true. But when a deductive argument has an invalid form, it is possible that the premises be true, but the conclusion false. By the way, this is extremely important. This slide right here, what's on this slide. So it bears repeating. This will probably show up on a quiz. The form of a deductive argument determines whether or not the argument is valid. When a deductive argument has a valid form, necessarily if the premises are true, the conclusion is true. But when a deductive argument has an invalid form, it is possible that the premises be true, but the conclusion false. Let's elaborate. Well, again, I say though, it's worth repeating. And I'll repeat it again. It's just one way to get this in your brains is just repetition. When a deductive argument has a valid form, necessarily if the premises are true, the conclusion is true. When a deductive argument has an invalid form, it is possible that the premises be true, but the conclusion false. All right, what do I mean? Well, it's possible for an argument to have true premises and a true conclusion and yet still be invalid. So take a look at this particular argument right here. If Davis is a human, then Davis is a mammal. That's the first premise. Premise 2, Davis is a mammal. Premise 3, so Davis is a human. All right, it's true that I'm a mammal. It's also true that if I was a human, I would be a mammal. And the conclusion that Davis is human is also true. I am human. But this argument's invalid, even though the premises are true and the conclusion is true. Well, why is it invalid? Well, let's take a look at the form. If P then Q, Q, whoop, see Q, whoop, Q again right there. So P, whoop, the conclusion, whoop, first premise. All right, that's the form. If P then Q, Q so P. Second, let's construct an argument of the same form with true premises again. If Davis is a squirrel, then Davis is a mammal. Davis is a mammal, so Davis is a squirrel. Now take a look. It's true that if I were a squirrel, I'd be a mammal. Squirrels are mammals. It's also true that I am a mammal. Yes, Davis is a mammal. The conclusion, though, is false. I am not a squirrel. So the argument has a true premise. Davis is a mammal, and if the argument has true premises. If Davis is a squirrel, then Davis is a mammal. Again, because squirrels are mammals, and I'm a mammal. But it has a false conclusion. I am not a squirrel. So on this form of the argument that we're looking at, it's possible to have true premises and a false conclusion. In which case, logicians would say that the argument is invalid. And in which case, the argument is invalid. Okay? So that's what it means for an argument to be invalid. It's a form in which you can have true premises but a false conclusion. If you have a deductive argument with true premises and a false conclusion, then that deductive argument is invalid, has an invalid form. Well, when you have an argument that has true premises and a false conclusion, logicians call that a counterexample to the argument form. Many weighty-sounding arguments are all invalid, by the way, because their form has, well, counterexamples. And many silly-sounding arguments are actually valid because their forms have no counterexamples. You'll be trained on how to tell the difference, which will take most of the semester. Uh-oh, my computer froze. Okay, well, here's an important point. Valid arguments can have false premises and a false conclusion. Again, valid arguments can have false premises and a false conclusion. For example, if Davis is a bro, then Davis sports a popped collar. Premise 2, Davis is a bro, so Davis sports a popped collar. This argument's valid, even though the conclusion's false. It also has a false premise. For one thing, I'm not a bro. And I don't pop my collar because I don't even wear shirts with the collar. But the argument's valid because of the structure. And it's that structure we've seen. If P then Q, P so Q. Here's a more obvious example. If Davis is a chicken, then Davis can lay eggs. Davis is a chicken, so Davis can lay eggs. I don't really need to explain why this argument has false premises. I'm not a chicken and I don't lay eggs. But again, the form is valid because of the structure or the form. The argument's valid because of the structure or form. If P then Q, P so Q. As you can see right there. So here's the big takeaway. The form of an argument determines whether or not the argument is valid. On the other hand, the content of an argument is irrelevant to whether or not the argument is valid. So again, the content of an argument is irrelevant to whether or not the argument is valid. I'm going to say it one more time. the content of an argument is irrelevant to whether or not the argument is valid. An argument can be valid with false content, ridiculous content, it doesn't matter. The content makes no difference to the validity of an argument. But the content is relevant to another good-making feature of arguments, and that's that second feature. So remember at the beginning I said that we're going to look at two good-making features of argument, validity and soundness. Well, now we're going to look at soundness. The second good-making feature of deductive arguments is soundness. Now, a sound deductive argument is an argument that is valid and has true premises. Remember this. A sound deductive argument is an argument that is valid and has true premises. Well, recall validity. You should, still know this. It should be fresh in your mind because I've just been talking about it for a long while now. A valid deductive argument is one such that necessarily if the true premises are true, the conclusion is true. It is impossible in a valid deductive argument that the premises be true but the conclusion false. So, a sound argument is just a valid deductive argument with true premises. Valid means that it satisfies this, and it has true premises. In which case, in a sound argument, the conclusion is true. So if you have a sound deductive argument, then you know that the conclusion is true. Or else, the argument would not be sound. If you have a deductive argument with a false conclusion, the argument is not sound. But if you have a sound deductive argument, then you can know that the conclusion is true. Most of this course, however, we're going to be spent looking at the first good-making feature, validity. And you'll be trained on how to spot when a conclusion really follows from its premises, which is a matter of form. Lastly, we need to talk about the usage of symbols in, well, symbolic logic. We're going to be using symbols and variables this semester. Because, well, logicians do it, and we're going to follow their example, and there's a lot of good reasons to do that. And we're going to explain these symbols slowly and let them seep into your brain and you can absorb it. Now, don't panic. There are many advantages to using symbols. For one thing, they're easier to manipulate. They provide an economical shorthand. They also allow you to see in a glance the overall structure of an argument. And they allow you to deal with more complicated arguments. Well, here's a worry. Perhaps you've never been good at algebra or math, stuff that uses lots of symbols. And now you're taking a logic class, which is just going to be a whole lot like that. Maybe you should have taken a different class, like the Kardashians or Kierkegaardian exploration. Well, here's my response. First, that class doesn't exist. Second, we're going to start slow. And we're going to use some very basic symbols for words you already use. And, not, or, for example. We're just symbolizing stuff that you already do. Finally, you'll find math easier to grasp after this course. Not because this course is harder than math, but because it will better prepare you for math. So, rather than being discouraged by the use of symbols, you should be encouraged. Well, there's two sets of symbols we're going to be using for the next while. In the first part of this course, covering what logicians call sentential logic, we're going to use a very easy symbol system consisting of single letters that represent sentences and special symbols for 5 logical terms, and, or, not, if, then, and if, and only if. And again, there's only 5 special symbols you're going to have to learn. Only 5. That's how many fingers are on your hand? 5. That's all the symbols you have to learn. Can you count to 5? 1, 2, 3, 4, 5. Bam! You're done. First 5 letters of the alphabet. A, B, C, D, E. Boom! That's all the symbols you have to learn. If you can learn to count to 5 and you know the first 5 letters of the alphabet, then you can learn these 5 symbols. I believe in you. In the second part of the course, we'll use additional symbols to break down sentences into their component parts, subjects, predicates, and quantifiers. But we'll get to that later. All right. May the force be with you.